Hello everyone, and welcome back. In last video we have completed the part 2, okay, where we have discussed about how to use ADC in FPGA, okay, using Xilinx system generator. In that video I have told you we can do ADC in two ways, okay, and we have discussed the first ways, means first method. We have discussed where we have discussed that we can do ADC by using IP catalog block and XADC wizard block, where the Verilog code is not involved, only block is used, okay. But also I have told you we can do the same thing using IP catalog and XADC wizard and generate Verilog code from that IP catalog block, okay, and that code is merged together and do the same thing, okay. I hope we have discussed these things in last video. So what is the process? Means you have to understand first how this Verilog code is work. Means you have to know about the hierarchy of the Verilog code and how these modules and sub modules are work, okay. So here you can see this diagram where we have a main module, okay. Main module, inside the main module we declare input and output, okay, and we have with the main module, inside the main module we have a sub modules, okay. Since we are using only XADC and MATLAB generated block, so we have two sub modules, sub module 1 and sub module 2. These sub module are connect, means instantiate, or in layman word we can say we connect XADC module with main module and MATLAB generated module with main module, okay. This connecting this XADC with main module we call this instantiation, okay. So we have to instantiate this XADC module and MATLAB generated module to our main module, and there are many things we will discuss later, okay. So basically you have to understand this, how the Verilog code hierarchy is working, okay. So I hope you all understand. So first of all, what we have to do, we have to generate this is the MATLAB code. So first we have to generate means IP block for this MATLAB file, okay, and these blocks are already we have discussed in previous video. So how these logics are working, so all these things are discussed, so we will not discuss here. We directly go to the system generator and generate, okay. So these things, so select according, this is the part, so select your device according. So in my case RTX 7 XC700T -1 CSG 324, okay, and compilation is IP catalog, and I choose a folder. Choose your folder where you want to store your project. So I have created one folder, ADC Verilog code, okay. So name is not important, and rest things are same as the previous video. So generate, so code is generating. So ignore warning. So you can see generation code is completed, okay, generation code is completed. So okay, okay, and now what we will do, we go to folder and go to the IP catalog and double click. It's take time, so yes. So as you can see, yeah, the folder this is our project, okay. If you double click this, you can see yeah, this one is our MATLAB generated IP block. So okay, now like previous steps, we do not need those steps. So unlike we have done in previous video, these things are different. So follow the steps that I am doing. Okay, so first of all, you have to remove this. Remove all. Remove whatever the file inside the design source. Remove. Okay, we do not need this, and create one file. Create a new source. So add source, click on add source, add or create source. Next, create a file name. I am giving file name since this is the main module. This is a main module, so give it name main module. Give the name main module and okay, click OK, finish. Okay, yes. So you can see we have created the main module Verilog file. Okay, now what we have to do, we have to okay, first of all, you can see our main module is created. Now what we will do, delete this line. Okay, now the second step is go to the IP catalog, click, left click, and search for XADC. Okay, double click. Now you can see XADC block is open, and do the same thing as we have done in previous video. Means configuration is same. Okay, so DRP choose single, since we are doing single channel. For double channel or more than, we will do in later videos. So I do not require reset to untick. ADC setup no change. So disable all alarms. Single channel choose, I am choosing as I have always choose Viox 11. Okay, summary you can see. Okay, now it's automatically open generate output product. Okay, so what this means, it generate the XADC wizard, which generate these files, instantiation template, all these things. Okay, so click to generate. Okay, now you can see, if you go to IP sources, you can see IP sources beside this hierarchy. IP sources, click, and you can see our XADC wizard is here, and inside, if you drop down, you can see XADC wizard instantiation template. Okay, so this provide two types of instantiation file. First one for VHDL code, and the second one for Verilog code. Okay, so double click, you can see this is our instantiation file. This whole code we have to merge with our main file. Okay, so first before that, you see we have a XADC instantiation file, but we do not have our ADC with Verilog that we have generated through MATLAB. We do not have instantiation file. Okay, so what we do, so for that, if you go to the IP catalog, okay, and search for your file. Okay, you search that you have generated IP catalog. If you search ADC, you can see the ADC is generated IP catalog inside IP. Okay, so double click. Okay, double click, it will automatically generate and generate output product. Okay, now okay, so this one is already present, so no need, delete this. Now if you go to IP sources, you can see you can find you can see the X instantiation template, okay, where two templates are present for VHDL and Verilog. For Verilog, if you double click, you can see this is the instantiation file of our MATLAB generated block. Okay, now we have an instantiation file. Now what we have to do, we have to instantiate to our main module. Okay, so first of all we have to declare our input and output. So first input is clock, so input clock. Okay, now we have to instantiate. Now we will instantiate first we instantiate XADC. So copy all the code and paste to main module. Okay, now we have just now we are instantiating our XADC, where you can give your name. This one is XADC V0 is the module name, and for instantiation you have to give name. So I gave name XADC module, XADC mode. Okay, now here you can see the pins, means the physically we see DIN, DA, DDR, the same things are here as we have seen in this. Yeah, you can see DA, DDR, DIN, DOut, all these things are present here. All these things are present. Okay, as we previously do, we add constants. Okay, we give the 0 values. All these things we have to do the same things in the code. So okay, now we have one input is clock, and the second input is what? Input. What we need, we are giving the input of Vox11. Control C, directly paste, Control V. Okay, and the second input is what? Sorry, third input is what? Voxn11. Voxn11. Okay, now output is what? Output is S switch 1 and switch 2. Okay, now DIN, what is DIN? What we do with DIN? You can see here DIN we gave 0 and the bit is 16 bit. So here we also do the same. Okay, so DIN gave DIN to 0, but it is how many bit? 16 bit. So 16 B 0. Okay, it means 0 of 16 bits. As you give the value to the specific pins, you can see we have not touched these blue ones. Okay, we have given we have declared the Vox11 N and P, and the blue shadow is removed. Similarly, you can see we gave the value of DIN and the blue shadow, and the blue shadow is removed. Similarly, what we have to do, we have to give address. Okay, so our input output declaration is over. Now there is two things in Verilog. The first one is register reg, reg, and second one is wire. The value which is stored that we declare in reg type, data type. Okay, and the simply wire is a wire, means connecting one thing to other. Okay, so if you will understand. So first of all, what we have to do, we have to address, means address I am giving. You can see address I am giving. So how can we, this value is connected with wire. Okay, so what we do, we simply write wire this whole things, copy, V is equal to what is the address of VOX11? Address of VOX11 is 7-bit in hexa. I am giving in hexa, so I write H1B. okay. Now you can see the blue shadow is removed from DADDR because I have mentioned the address of VOX11. Now DEN, what is DEN? If you see DEN, where is DEN? Yeah, DEN is connected with EOC. Okay, so what we have to do, wire, we declare this EOC is a wire, it is a wire. Okay, now the shadow is removed. EOC is wire which is connected to what? DEN. So we have to connect Control C EOC out to DEN. What this means? We simply connected EOC out to DEN. Okay. Now this is DWE. What we do with DWE? We give 0 to VN in, VP in, and DWE. We gave the constant value of 0. So here we do same things. So give the value of 0 since it is a 1 bit. So 1, B 0. Okay. Similarly for VPN, same thing. We gave 0. Control C and VPN V. Okay. Now we have only data ready. So data ready is simply we do not do with it. We do not think with data ready. So give simply a wire. So each and every pins we have to declare. Okay. Otherwise it will show error. Clock we have declared here, clock input we have declared here, clock input. So just give in CLK clock. Okay. Now DO out simply a wire. And this channel out is also a wire. Of how much it is? The bit of 5 bit. So I generally copy these things because I do not want any spelling mistake. But here we can also give a bit size of how many bit? This is a 16 bit, 15 to 0. Okay. What else? These things are, you can simply kept it as it is. Do not declare any things. Okay. I hope we have declared all things. Okay. So now you can see the all blue shadows are removed. Okay. Now we have to instantiate what? We have to instantiate this ADC Verilog, which we have generated through our MATLAB. So copy this one, Control C, and paste to your main module, Control V. Now and just give the name whatever you want to give. So I gave name MATLAB generated. Okay. You can see we have all these four variables are there, and already 3 out of 3 we have declared, like clock is input and switch 1 and switch 2 is output, and the only thing is ADC in. So ADC in we have to connect, it is an input to what? It is an input of DO out. Okay, so simply so the output of the XADC is connected with ADC in. So how do we do? Can we directly connect to DO out? No. So what we need to do? We have to do one simple thing. So we have to follow the steps that I am doing. So we have to write always pose TGE. Begin. Now we have to make one logic. If channel out is equal to what? If channel out is equal to, since it is a 5-bit, 5B, what is the value of Vox 11? Vox 11 is in hexa, the Vox 11 value is 1B, but in binary Vox 11 value is 11011. Okay, you can convert it, you can check it. Okay, now if our channel output is this much, then what? Then we have to store the ADC value. So ADC data. So I am storing ADC data from where? DO out. Okay, from DO out I am storing ADC data. Okay, else what? If not, channel out is not equal to 11011, then ADC data is equal to what? 0. Since DO out is 16-bit, so here I am taking 16B, means 16-bit. Okay, and now it showing error, means ADC is not declared. Okay, you can see error, ADC is not declared. So first of all we have to declare ADC data. So since we are storing ADC data, okay, so what is the data type? It is a reg type. Okay, ADC data, how many bit? We select 16 bit. Okay, you can see the error is removed. Now what we do, since our ADC DO out data is stored in ADC data, so we have to extract this ADC data. So what we do, assign this ADC data to what? ADC in, means I am transferring this ADC data to ADC in. Okay, is equal to ADC data. Okay, ADC in is ADC data, whatever the data which is stored, that is transferred to ADC in. Now you can see ADC, we have not declared any ADC, so we have to declare ADC. Since this is, I am not storing ADC data to ADC in, this I am not storing the data in ADC in, I am simply connecting this ADC data to the ADC in. Okay, I hope you understand. It is simply a wire, means connecting our made file ADC in. Okay, so it is a simple wire ADC in of how many bit? We are taking bit of, as I have told you, this is a 12-bit, so I am taking from MSB, so from 15 to 4-bit. You can see the blue one, the blue shadow which is earlier present is removed. Now our code is completed. Okay, we have declared input output and declared the instantiation and connect with the main module. We have declared XADC wizard and instantiate with a main module. Similarly we do one logic we have to do this, and we have instantiate our MATLAB generated file with main file. Okay, so looks good. So we have completed. Now the next step is what? So first of all, save it, and okay, if you see the main module, this, and within the, if you see the sources here, you can see main module is in top, and within this main module, updating. So within this main module we have a XADC module and MATLAB generated module. Okay, so now the next step is, the rest is same. We have to do synthesis, implementation, generate bit stream. Okay, now we synthesize our code. Synthesis is completed. Before implementation, as we do before implementation, what we have to do, we have to declare input output pins. So go to the schematic. These things we have done so many times. Okay, this is the synthesize. So we have a 5 input output. So click, you can see Viox 11, switch 1, 2, clock. So what we have to do, we have to make them LV most 3. And declare name. So Viox P11 is B18, switch 1 I am taking the name of G14. Okay, switch 2 P15 and clock is E3. Okay, so XDC file is completed. So Control S, save it. This is our XADC file, means in declaring input and output. Okay, now the next is we have to do implementation. Now implementation is completed. The next step is generate a bit stream. Bit stream is generated. Now we have to connect our FPGA and program it. I have connected the FPGA and programmed. Now you can see the sensor is connected to the FPGA. Okay, someone asked about the blue wire. Blue wire is connected to Viox negative and ground, and the gray one is for one Viox. Okay, and the orange one is for positive and gray one is for negative. Now you can see the ground black wire is connected with two scope. I am using oscilloscope, so ground is connected with 2, and the red wire you can see is for one output, and white is for another, switch 1 and switch 2. Okay, now you can see in scope we have a time scale of 5 millisecond, means you can see 2 boxes, means 10 millisecond. For 10 millisecond one half, and the other 10 millisecond for another half. So you can see pulses for one half and another half. Okay.